In this video, I'm going over the questions from quiz 8, as well as about maybe half of our questions from the mock, some of those most missed questions from mock 3. So in question number 1, and again, guys, make sure to take a look at the version. So I do have each of the numbers in regards to what version and what number it is on yours, because I'm following version A. So in question number 1, you had to look to see which of these characteristics describe the graph. So here I'm just going to kind of quickly go over, but there were quite a few people when I was looking at data who said that the answer was B. But here in this case, the answer was not B. So as x values are approaching positive infinity, so as the x values are going towards positive, right? So that's to the right here, towards positive infinity, notice what direction is the end of that right side of the graph approaching. Well, it's going up towards positive, but this statement said negative. So that's why it wasn't B. The answer in this case was actually C. As x values approach negative infinity, so as we're going to the left here, negative infinity, what direction is the left side of the graph now approaching? It's going down to negative infinity. And there were some people who did choose D. Notice how, guys, that the multiplicity for each of them was a slice, right? So all the exponents are 1, but notice how the signs stayed the same. So see how that's -2 and +4 and -2 and +4? Remember, when writing the equation in factored form, you have to change the sign. So this was supposed to be x times x plus 2 times x minus 4. So question number 2, you had to see how many solutions. So this is when you're having to calculate the discriminant, b squared minus 4ac, where then you can identify, because our equation's equal to 0, so we're good, your a, b, and c values. Now the key is this: you have got to make sure, if you're putting this in the calculator, that you put it in correctly, because b being -20 here, you have to put that in parentheses, -20, and then to the second power on the outside. Because if you don't, then the calculator is going to say that's -400, when this is actually +400. Then minus 4 times A, which is 5, times C, which is 20. So in this case, you end up with 400 minus 400, which is actually 0. So now you got to go back and look at the answer choices. Well, it's not A, because 2 real is positive. It's not 0 real to imaginary, because that's when the answer is negative. Then you just have to remember, either you will have real solutions or you will have imaginary. You will never have both. You will never have one real, one imaginary. So that's why here, guys, with a discriminant of 0, that shows 1 real and 0 imaginary. So the answer was B. Question number 3, so look for this one on your version. And this is just simplifying. So I'm going to focus on the numerator. I see I have 2 terms here, right? So usually there's the 2 terms like a difference of 2 perfect squares, but this is not a difference of 2 perfect squares. Actually, you know what? I'm going to go to the denominator. See how the denominator, this is the difference of 2 perfect squares, because I can take the square root of both of those values. So this, in factored form, the denominator is x plus 6 times x minus 6. So that is, again, the difference of 2 perfect squares. Versus the numerator, that's just the 2 terms, but not a difference. So I'm going to take out GCF. Well, I notice between 8 and 48, I have a GCF of 8, but they also both have an x. So I'm going to take out 8x. So now when you divide out 8x, you end up with just x, but then minus 48 divided by 8, which is 6. So now here I can cancel out x minus 6, and you're left with C, 8x over x plus 6. Question number 4, so look for this one on your version. And notice how from the function notation, we are multiplying these two functions. So no need for keep, change, flip, right? Because this is just straightforward multiplication. So I'm going to go ahead and set up this problem with my f of x and just multiplying. No need to flip it because we're multiplying. Now I'm going to go ahead and start focusing on my numerators, right? Because we're just multiplying straight across. Basically, everything here is going in the numerator after I factor it. So I have a trinomial now, right? Notice how we've got like an A, B, and a C. So what numbers multiply to get us 18 positive, but add to get -9? -6 and -3. Then here, oh my goodness, my dog is snoring next to me. If y'all can hear that, I promise that's not me, that's my dog. Moving on, then the other numerator. So here, I'm now back to just two terms, 5x plus 25. It's not a difference of two perfect squares, so I'm going to take a look to see if there's a GCF, which in this case, you have a GCF of 5. So I'm going to take out 5 here, and you're left with, well, 5 divided by 5 is 1, so that's just x plus 25 divided by 5, which is now 5. With a GCF, I personally like putting the GCF on the outside. You see I have that 5 value there, and then x plus 5. Now the denominator. Here, and I'm back to two terms. So do I have a GCF because it's not a difference of two perfect squares? Yes, I can take out 5. So now 5 divided by 5 again is 1, and 15 divided by 5 is 3. So this is now, I'm going to put my GCF on the out in the front, then times x minus 3. Then the next denominator, can I factor x plus 5? No. X is all by itself, so I'm just going to rewrite that, bring that in. Now I can start canceling. X minus 3, x plus 5. Now notice, here you go. What is 5 divided by 5? 1. So that just also cancels out because you're left with 1. Your final answer is just x minus 6. So now go to question number 5, find this version. Now notice here you are dividing, so we do need to keep, change, and flip. So we do need to keep now the first fraction. This is for division. But then remember, right, now we're going to multiply, flip the second fraction. So now it's 5x plus 35 over x squared plus 19x. Now, same as before, we start factoring, and I'm going to go ahead and start factoring all of my numerator because we're just multiplying straight across. So now notice here, this first numerator, we're back to two terms, and it's a difference, we're subtracting, of two perfect squares because I can take the square root. So this is x plus 9 times x minus 9 because the square root of 81 is 9. Now I'm going to go to the next numerator, back to two terms, but not that special case of the difference of two perfect squares. So do we have a GCF? Yes. You can take out 5. So this becomes, well, 5 divided by 5 is 1, so 1x, and 35 divided by 5 is 7. So I'm going to put that 5, my GCF, on the out. So I've got 5 and then x plus 7. Now the denominators. Notice we have a trinomial, so here's my a, b, c. So a is 1, x squared is by itself. So what numbers multiply to get you -63 and add to get you -2. So again, focus on factors of 63. So what are factors of 63? 9 and 7. So here I'm going to use 9 and 7, in this case, -9 and +7. So now I'm going to go to my next trinomial. Again, x squared is by itself, so I can go straight to parentheses. What numbers multiply to get 90 and add to get 19? 10 and 9. So x plus 10 and x plus 9. So now I can start canceling out. X plus 9, x minus 9, and x plus 7. Notice how you're just left with 5 over x plus 10. So that's why here the answer was C. Question number 6 now. Look for this one on your version. This is I to the higher power. So notice how we have -2 being raised to the third power. So -2 to the third power. That's going to give you -8. So here I've got -8. Then we have our I. But remember here, right? Power to a power. So what do we always do? Multiply. So that is 27. Now you can start the quarter method where we divide by 4, and then you should have gotten 6.75, which here, notice there are 3 quarters. So this is still -8, but now times I to the third power. I to the third is always -I. So negative times a negative is a positive, 8I. Question number 7. Now, this was one of also just overall from Algebra 2, one of our most missed questions, the 2 graphs questions. So question number 7, look for this one on your version. We're looking to see which statement is true. Use test-taking strategies. Well, I notice I'm only focusing on which interval? From -4 to -3, right? So I'm going to focus on those x values. Remember, interval is about x values. So on the x-axis, here's -4, here's -3. So we're only focusing on this section of the graph here. So notice how this portion of the graph is above the x-axis, right? And all of the values, y values are positive. So that means all of the values are positive, not negative. So I'm going to mark off C and B. So now I'm down to A or B because those values are positive. Well, remember now, always read the graph to see if it's increasing or decreasing. Always read the graph from left to right. So the most common mistake was people chose A because you see the arrow here and go, oh, well, it's going up, so it's increasing. But that's just the end behavior. Read the graph from left to right. What direction is the graph actually going, that portion? Down. It's decreasing. So that's why the answer was B. Read the graph from left to right and notice how it's going down. So don't focus on the end. Focus on reading the direction from left to right. That's why it's B. Question number 8. So what was the conjugate? So remember, guys, the conjugate. The conjugate is when when you divide complex numbers. Like if I had 2i over 20i minus 7, we always multiply by the conjugate. So what is the conjugate? That's all this question was asking for. That's it. So remember, the conjugate is just when you change the imaginary part. So all you had to do was change the I. Well, first off, I'm going to go ahead and notice that this is the same as -7 plus 20i. So the answer cannot be C because that's the same exact thing that I gave you. The conjugate is when you change the sign of the imaginary part. So in this case, instead of positive 20i, it needs to be negative 20i. That's why the answer here was D. That is the conjugate. Question number 9. Look for this question on your version. Now notice, this is like having an x to the higher power. I'm going to look at my answer choices. Notice the setup, kind of like with a remainder here. So this is division, and this is a long division problem because you have 2 here for your coefficient. So I've got 2x plus 8. Now, with division, always check to see if you need a 0. So did we need a 0 in this case as a placeholder? Yes, because you're missing x squared. So this is 2x cubed plus, 0x squared minus 14x plus 82. So you did need a 0. Now I'm going to start the division. Always divide, right? First term into the first term. Well, that's just 1. Then always 1 less x, so x squared. Then multiply. Well, 1 times 2, that's always going to match up. So there's my 2x cubed but don't forget to multiply the 1 to the positive 8. 1 times 8 is 8, and x squared. But before you combine, what do you have to do? Change the sign. So now they're both negative. So that cancels out, right? Always. 2 minus 2 is 0. But 0 minus 8 is negative 8, x squared. Then bring down the next term. So now divide the first into the new first term. So now I'm going to divide 2, but now into what is the new first term? Negative 8. 2 goes into negative 8, negative 4. So negative 4x. Now I can already notice from test taking strategies, that means my answer has to be A. And again, just to show y'all, when you multiply, right, that's going to match up. You get negative 8x squared. But don't forget to multiply the negative 4 to the positive 8 again. So that's going to give you negative 32, negative 4 times 8. Then change the signs. So now they're both positive. That cancels out. Negative 14, but now plus 32. That's now going to get you 18x. Bring down positive 82. Then divide again, first term into the new first term. So 2 going into 18. 2 goes into 18 9 times. And then again, keep on going, right? So when you multiply, they match up. Oops, sorry. They match up and you get 18x, but don't forget to multiply the 9 to the 8. So that's 72. Change the signs. So now they're both negative, and that's how you get a remainder of 82 minus 72, which is 10. That's how you get A. Last one, question number 10. So this was our binomial expansion, where here you had an exponent of 3, so you're going to use 1, 3, 3, and 1. Then the first term is 4x. So don't just put 4x, keep it all together in parentheses. All together in parentheses. And the exponent, 3, then count down to 1, 0. Then the second term is negative 2. So here I'm going to multiply, keep it all together, right? In parentheses again, negative 2. And remember now with the exponent, count up, 3, 2, 1, 0. So now we can start our expansion. The first line, well, that's just 1, anything times itself, and then anything to the 0 power is also 1. Now be careful because that's not just 4x to the third, right? That's why we keep it in parentheses, because that 4 is also being raised to the third power. So now what is 4 to the third power? 64, and x to the third. So that's why I'm going to mark off A and B. And let's go to the next line, C. The most common mistake is people just want to multiply 3 times 4 times negative 2. But again, you're missing one little piece here. So notice how we do have our 3. So 3 times, that is 4, yes, but being raised now to the second power. So what is 4 to the second power? 16. So 16x squared, not 4. Then times negative 2. When you multiply all 3 of those values together, you should get negative 96. That's why the answer was C and not D. Oh, there goes my dog again. So now the bonus question. The bonus question gave you the width. The width of the rectangle is this expression here. The area of the rectangle is this expression here. You are looking for the length. So again, area is equal to length times width. But if I'm given the area and I'm looking for the length, that means you're going to divide to solve this problem, that area the area by the width. So you had to set this up. So some people, you just did it in order. You had to make sure to read the order. So it's always the area. So you're going to divide this problem. However, this is a keep, change, flip because you're dividing. So I'm going to keep the first, which is actually the area. So I'm going to keep negative 2x squared minus 6x because that's the area. That's what you were supposed to put first. Then multiply by the width or the reciprocal, right? Remember, we're dividing, so you need to flip it. So it's x plus 9 over negative x. Now, with our numerators, here we go. We're going to multiply straight across. Here is our special case. Now, I notice I have a negative out in front. So I'm going to factor out a negative. Then notice how they both have 2. So I can take out 2, and they also both have an x. So the GCF was negative 2x. So now when you take that GCF out, you are left with just x. But now remember, right, if you take out a negative, then that means, think of negative, you're changing the sign. So now it's not x minus, but now x plus, and 6 divided by 2, which is 3. Then here, the second. Can we factor? No, that is not a special case or anything, and x is just by itself. So x plus 9. Now go to the denominator. Now we're back to a trinomial where x squared is by itself. So I go straight to parentheses. What numbers multiply to get you negative 90 and add to get you negative 1? Negative 10 and positive 9. So negative 10 and positive 9. Then here we've just got negative 8x. So you know what? I'm going to go ahead and erase what I just put here. So I'm going to go ahead and line up that value, the negative 8x, out in front. So again, x plus 9 times x minus 10. Now I'm going to start simplifying. Well, I can cancel out the x plus 9. Now notice they both have x. So the x's are now gone. Also notice that 2 negatives will make a positive. So technically that cancels out. And you have 2 over 8. 2 over 8 is 1/4. So this now becomes x plus 3. 1 times x plus 3 or just x plus 3 over 4 times what? X minus 10. So I could rewrite this as x plus 3 over 4 times x minus 10, or distribute the 4. And you have x plus 3 times 4x minus 40. That was the length. So now we're going into the mock questions, and these questions are some of those most missed. So like, for example, a lot of these now you're going to see that we brought them back on the quiz because they were some of our most missed in getting y'all that practice. So like, for example, this was from the mock. Notice how, same as before, where you have the -2 here to the 5th power. So that's not going to multiply. -2 to the 5th power is -32. Then what do you do with the I? Multiply. So that's now I to the 35. Then start the quarter method. So when you divide by 4, you end up with 8.75, which again is 3/4. -32 times I to the 3rd. I to the 3rd is always negative I. 2 negatives when multiplied make a positive. That's why the answer was positive 32I and not negative 32I. This one now we didn't spiral back, but was also another one. Now notice how you're looking for the value of n, but I notice here that I'm subtracting. So I like making sure first to distribute the negative to see what we're actually working with. So this is the same as 7 minus 4i, but minus 9 plus ni is equal to -2 plus I. So now we're looking for what's the value of n. Well, n is what? Imaginary. So I only need to focus on imaginary parts. So what else is imaginary? The -4i. What else? Positive I. So this is -4i plus ni is equal to just I, or 1i. So really, you're just looking for -4 plus what value is going to equal 1. That's why here the answer was D. -4 plus 5 is equal to 1. This was the quadratic formula, which we actually showed improvement on. So just to kind of show y'all, and great job on that. Because here we do need to distribute. X squared minus 4x is equal to -9. And then always have to equal 0. So add the 9 here to both sides of the equation. X squared minus 4x plus 9. Then quadratic formula. So x is equal to -b plus or minus the square root of b squared minus 4ac over 2a. So I just wanted to show y'all this question, but y'all showed great improvement on this, so I'm going to move on. But I wanted to just kind of put that in there and say great job on that. This one was also one of our most missed, and this was long division, because you have what is the width? What is the width? You're given the length, which was 5x plus 2, and the area was this polynomial here. So this is division because you're given the area. So when you set this up, you have 5x plus 2. But the reason why this was the most missed, and thinking about that quiz question, is because people did not look to see if you needed a 0. So notice, guys, do you need a 0? Yes, because you were missing the x squared term. You had to set this up 50x cubed, but then plus 0x squared plus 2x plus 4. So don't forget about if you need that 0. So now dividing the first into the first, 5 going into 50 10 times with 1 less x. So now when you multiply, that will match up, right? So that gives you 50x cubed, but don't forget to multiply the 10 to the positive 2. That's how you get 20x squared. But before you combine, change the sign. So then now they're both a negative. So that's 0 gone, but negative 20x squared. Then bring down positive 2x. Then divide the first term 5 now into the new first term. That's 5 into negative 20 now. So a lot of people got tricked up because you were having to get something else. That was where the 0 came in. So here you get -4, -4x. So I'm going to mark off A and B. That gives you -20x squared. Then multiply. That gives you -8x, because multiply the -4 again to the positive 2. Change the signs again now to both a positive. That gives you 0. Then 10x. After combining, bring down positive 9. Then here, divide the first into the first. 5 going into 10 is just 2, positive 2. That's why the answer was C. This one, just to kind of reiterate, the most common mistake was kind of like that question that people chose the factored form of the equation. You have to remember to change the sign. So the most missed answer was B, because people saw how here we're crossing at -3. People saw how we have a 0 at 2. Then you kept the sign. You notice the multiplicity, like for example, at 2, you have a bounce. So I need that multiplicity of 2. But again, change the sign. That's why instead of putting -3, you need +3. And then instead of +2, you need -2. Then here, notice at 0, you have the slide, you have the bend, which is a multiplicity of 3. That's why you need x cubed here. So that's why the answer was D and not B. So don't forget, with factored form, change the sign. And this was our other most missed question. So again, the graph. You were looking to see if the student sketched this. So you're looking for 3 real zeros. Well, each have a multiplicity of 1, 1, 2, 3. So that was true. Not 4 real zeros, but we do have 3 real zeros. Then here as for end behavior, as x approaches positive infinity. So as we're going to the right, towards all the positive. So as x is approaching positive infinity, they're saying that the f of x was supposed to approach negative infinity. So what is the direction that the right side is approaching? Well, you should have noticed it's not going down, it's going up towards positive infinity. That's why the answer was A. As x's are approaching positive, the f of x were approaching positive. Here, notice how as x approaches negative infinity, so going to the left here, what direction is the left side approaching? Negative infinity. So that part was true. And here, that's why we brought this one back on the quiz. Because this was, again, how many solutions? So b squared minus 4ac. The most common mistake was people chose C. Again, you just have to remember you will never have a one real, one imaginary. Either you're going to have real solutions or imaginary solutions. So here, b squared, 40 squared minus 4 times 100. Then you get that discriminant of 0. So that's why the answer was B. Then again here, same thing. That's why we brought this back on the quiz. Which represents the conjugate? So again, the conjugate is just changing the sign of the imaginary part, like when you're dividing complex numbers. So notice how here this is -9 plus 15i. That's what we gave you. The answer is not A, and that's the common mistake. If I gave you -9 plus 15i, change the sign of the imaginary part. That's why the answer here was C.